Example number 5.10. Okay, a body of mass 0.4 kg moving initially with a constant speed of 10 meter per second to the north, and it is having a constant force of 8 Newton which is directed towards the south. The object is moving in this direction and you are applying the force in the opposite direction. Okay, so the body will stop after some time, and if the constant force is continuously on the object, then the moving body which was earlier moving in this direction will stop, and then it will change its direction and it will start moving in the south direction. Try to understand this whole process. Okay, directed 8 Newton is directed towards the south for 30 seconds. You are applying this force for 30 seconds and this phenomena occurs. The object was moving in this direction, stops, and then it changes and it goes in this particular direction. Okay, take the instant the force is applied to be t is equal to 0. The position of the body at that time to be x is equal to 0, where you are applying the force. Okay, initially when you are applying the force, the position is x is equal to 0 and t is equal to 0, and predicts its position at t is equal to minus 5 seconds. So before application of the force, the time is taken is minus 5. Try to understand, time cannot be minus 5, but here before the application of the force, the body was moving with constant speed, and before the application of the force, okay, the body was having constant speed. Try to understand this part. And before that, before the application of the force 5 seconds earlier, what was its position that we want to find? At 25 seconds, then at 100 seconds. Okay, this we want to calculate. Okay, now see, first of all, we find out the acceleration because of the application of the force. So acceleration is nothing but force upon mass. Now the force is minus 8. Why? Because it is in the opposite direction of the motion, and the object is having the mass 0.4 kg. So this acceleration will be minus 20 meter per second square. So this is very easy to calculate. Now first, position at t is equal to minus 5. T is equal to minus 5 seconds, means before the application of the force. Okay, so that position d1 is equal to u into t. It was moving with constant speed, rather velocity. It is moving in north direction. So here at this point, if the force is applied, then its position before that application of the force, application of force is taken to be at t is equal to 0. So before application of the force, it must be somewhere here. Okay, and that we want to find out. Here it was. Okay, and in 5 seconds it came here, and you are applying the force at this point. Okay, so that will be 10 into minus 5, that is minus 50 meter. So from this point where it was started experiencing the force, okay, it was 50 meter behind, mean that is why the negative sign is significant here. Okay, now we shall find out position at t is equal to 25 seconds. Okay, so position, now it is accelerated motion, so we can use this formula, say d2 is equal to ut plus 1/2 at square. Initial velocity is 10, time is given 25 seconds we want, plus 1/2, acceleration is minus 20. Okay, minus 20 and the square of 25. If you simplify this, square of 25 and all, then you will get minus 6000 meter, or we can say 6 kilometer, minus 6 kilometer we can say. Okay, now position at t is equal to 100 seconds. Similarly you can calculate, say d3 is equal to ut plus 1 half at square. So d3 also can be calculated. 10 is the initial velocity. Okay, position at t is equal to 100 second. Okay, first motion up to 30 second we consider. Okay, so first of all up to 30 second, okay, we shall consider this, because up to 30 second the force exists, so it is an accelerated motion. So in 30 seconds how much distance does it cover, that we shall first calculate. So for first t is equal to up to 30 second we shall calculate, because this formula can be applicable for the accelerated motion. That is why first at 30 second what is its position, that we shall find out. So we write instead of t as 30 plus 1 by 2, acceleration is minus 20 and square of 30. Okay, and if you simplify this, then you will get minus 8700 meter or 8.7 kilometer, we can write 8.7 kilometer. Okay, with negative sign. Now after 30 second motion is with constant velocity. Try to understand, after 30 second the motion is with constant velocity, but because of the force its velocity has changed. So at 30 second what is its velocity, that can be found by v is equal to u plus at. What is the velocity at 30 seconds? Now u is given to us, or rather we have this value 10, plus acceleration is with us, that is minus 20, and time is 30 second, because after 30 second what is its velocity, and that can be found to be minus 590 meter per second. So its velocity at 30 second, velocity at 30 second is found to be this minus 590 meter per second. And now at 100 second, means next 70 seconds, it is moving with this constant velocity. Okay, the velocity is now constant for this, so we can easily calculate the distance travel. Now we do not have to use this equation of accelerated motion, just we can use our simple equation, that is, say d4 is nothing but the value of velocity multiplied by time. The value of velocity we got, it is minus 590, because it is moving in negative direction, into next 70 seconds. Distance is equal to velocity into time. So this you will get 41300 meter with negative sign. So it becomes minus 41.3 kilometer. So total distance is nothing but, total distance covered will be d, and that is equal to d3 plus d4. Okay, and that you can add minus 8.7 kilometer and this minus 41.3 kilometer. So it will be 50 kilometer. Okay. Now 5.11, a truck starts from rest and accelerates uniformly at 2 meter per second square. At t is equal to 10 second, a stone is dropped by the person standing on the top of the truck 6 meter high from the ground. What are the velocity and acceleration of the stone at t is equal to 11 second? We are neglecting the resistive forces. Okay, so initially say the velocity of the truck. Okay, initially first of all we shall find the velocity of truck and velocity of stone simultaneously. With the same velocity it must be moving. Okay, and it is an accelerated motion, so v is equal to u plus at, because truck is moving with a constant acceleration of 2 meter per second square. So in 10 seconds what is the velocity of that truck can be found, 0 plus 2 into 10. So this becomes 20 meter per second. Okay. Now for the horizontal motion, velocity is 20 meter per second. Say for example, this is the truck and the stone is moving also with the truck, okay, with 20 meter per second, and at that moment it is dropped, so it is having its initial velocity to be 20 meter per second. For the horizontal motion, the velocity is 20 meter per second. Now consider vertical motion, and this is due to the gravitational force, okay. So because in this vertical motion there will be an accelerated motion, that is due to the gravitational acceleration, say 10, we take meter per second square, okay. And when it is dropped, it was having its horizontal velocity, say this is the horizontal velocity we take is at Vx, but its vertical initial velocity was not there, or vertical motion it was not doing. So in vertical direction the initial velocity is 0. Now in 11 second, now in next 1 second, okay, 10 second it has been accelerated in x direction, it was moving in x direction with 20 meter per second at 10th second. Now in 11 second, means in next 1 second, okay, what is the velocity in y direction we want to find. And as you know that this is accelerated motion in y direction, so in y direction we take the formula u plus at, that of accelerated motion. Initial velocity in y direction is 0, acceleration is due to gravity into time is 1 second, so it becomes 10 meter per second in y direction, okay. Now resultant velocity we want to find, one is in x direction, the other one is in y direction, okay. One velocity is in this direction, that is Vx, the other one is in y direction. So resultant can be found by using the Pythagoras rule, or this can be easily calculated. Vx square plus Vy square, Vx is 20, so 20 square plus 10 square, okay. And if you find this, then you will get about 22.36 meter per second. And if you want to find the angle, say this is the direction of resultant velocity, then it is Vy upon Vx, okay. Tan theta, as you know, it is y component upon x component, so Vy upon Vx, and Vy is 10, the other one is 20, so 10 by 20 is 1 by 2, that is 0.5. Locate that value from natural tangent, and corresponding angle will be about, theta will be about 26, okay. Theta will be about 26.5 degree with the horizontal direction, okay. When stone is released from the car, that means its motion is only under gravity, so acceleration along horizontal direction is 0, while acceleration in vertical direction will be 10 meter per second square. So net acceleration is in vertical direction, and that will be 10 meter per second square, or we write it by Ay, okay. Acceleration in vertical direction will be the acceleration, okay.